Hello, you beautiful people out there. Welcome back to Tensorvid. This is the part where most people's designs fall apart. Literally. The hinge joint connects the top and bottom clamp components. And no, it's not just a simple cut and pin situation. We're going to design it with the right movement clearance, use section analysis to inspect internal gaps, and make sure it prints as one piece with working motion, straight off the printer bed. Before we create the hinge piece, let's work on the front portion of the top and bottom clamp pieces to create a hatch-like feature. We can then add holes and threads so it can be tightened onto a roller using a nut and bolt. The most effective way to create this hatch is to go back to our initial sketch. So, I'll go to the sketch in the timeline, right-click, and select the Edit Sketch option. Now that we are in the sketch environment, I will take the line tool and create two adjacent lines at the beak or tip of the clamp. I will then give each line a dimension of 14 mm. And then mirror it to the other side. Let's click Finish Sketch. I will temporarily hide the top and bottom clamp components so we can easily select the necessary faces for extrusion. Now, unhiding both components again, let's extrude the faces by 20 mm. We need to make sure it's extruding symmetrically and as a whole length, and that the operation type is set to cut. Once that's done, I'll hit OK. Great, we now have a hatch feature. The next step are to create the holes and the threads. But before doing that, I'd like to add a bit of a fillet to these two edges. I'll set the fillet value to 85 mm so that it matches our inner diameter. You are welcome to add fillets to more places, but I will stick to just these two. Let's start creating the holes now. I'll take the sketch tool and select this upper face. Let me zoom in a bit. I want to create the hole right at the center of this face, but I'm unable to snap to that center point directly. The trick here is to create two diagonals from the corners, as the intersection of those diagonals will define the center point. I can't immediately tell which corner point is the correct one. What we can do is project the face's geometry onto the sketch so we can see the anchor points. To do that, go to Create, then Project, Include, then Project. Then, select the face we want to project and hit OK. Now we have our anchor points. I'll draw the diagonals and turn them into construction lines. Now we have our center point, so we can create a circle from that center. I will draw a 5 mm circle and turn it into a construction line. There are multiple ways to proceed, but I want to teach you more about Fusion 360. We can now use the hole tool. Oops, not that one. Let me grab the hole tool and create the hole from the center point. For the distance, I will set it to all. I'll make the diameter 5 mm and then click OK. There you go, we have our perfect hole. Let's now add the threads. Go to Create, Thread, and select the face where we need to add the threads. Notice that it doesn't allow us to select multiple faces yet. Let's cancel that. Instead, I'll select both faces where the threads will be applied first and then repeat the last process. It has automatically selected the correct profile for the thread based on the diameter. These threads are just a projection for now, not actual threads, as you can see when I zoom in. To make it a real thread, we can enable a model checkbox. And there you go, it is now a perfect model thread. Since everything is a component, we can easily move them. If you'd like, you can give colors to the components by typing A on the keyboard to open the Appearance panel and then search for a color. As you can see, the back portion of the top clamp looks a bit odd. Let's diagnose the issue. Ah, there it is. We forgot to cut the inner portion near the hinge area. A silly mistake? Not really. It's not so silly when you remember we can always go back to the sketch and add that cut. We can literally time travel in Fusion 360. I will unhide the sketch and hide the clamp pieces. Then I'll select the Extrude tool and select the necessary faces. Now, unhide the top clamp. Using the same options as before, we'll set the distance to 20 mm and the operation type to cut. And there you go. We fixed the issue and can clearly see the clearance between the two pieces. The only remaining element to model is the hinge piece that will hold these two parts together. So let's get right into it. I'll create a new sketch and select the YZ plane. I will draw a circle with a diameter of 40 minus the clearance value. If we finish the sketch and go back to the model, let me remove the existing joints and move this component away. As you can see, we have a circular opening on both sides for the dumbbell-shaped pin to be held in place. We need to create this opening, the socket, in the top clamp. So, I'll take the sketch tool and select this face of the top clamp. We will project the face onto the sketch to get the center point. I'll draw a circle with a diameter of 60 mm. Let's finish the sketch and take the Extrude tool, selecting the ring we just created. Now, as you know, the total thickness of the clamp is 40 mm and each of these faces is 10 mm. So, we will give this face an extrusion distance of minus 5 mm. Now, we need to do the same on the other side. The best way to do this is to use the same sketch but start the extrusion from the opposite face. I take the Extrude tool again and in the Start option, I will select Object. Let's pick this face as the object and extrude it 5 mm. I'll hide the sketch now. Perfect. We have our sockets ready to hold the pin. Remember that I made the socket 60 mm in diameter. I will now go back to my sketch and create another circle right from the center. And give it a diameter of 60 minus the clearance. Again, we want the rolling pin to not just hold the pieces together, but also allow it to move freely without creating too much friction. Let's finish the sketch and unhide the sketch we just created. I will take the Extrude tool again and select the inner circle. Making sure the direction is symmetric and the measurement is whole length, I'll extrude it 40 mm, which is the thickness of our clamp. The operation will be new component, and I'll hit OK. Let's rename it. I will call it the hinge, but you can call it anything you want. We now need to extrude the outer circle from the same sketch such that it fits into the socket we created on either side. With the circle selected, let's change the Start option to Object and select this face as the starting point. I will extrude it inward. If you remember, the socket has an extrusion value of 5 mm. We will give the same distance here but with the added clearance so it moves freely. I'm turning the equation into a mathematically correct expression by adding parentheses. Let's do the same on the other side. "5 mm minus the clearance." See how easy it becomes when we have a parameter set. Now comes the fun and satisfying part, assembling each part together. Let me move the top part to the side. What we do is take the joint tool, located under the Assemble options here. We then select this face right here and its center. Then we select the other face, where it will touch, and the center of that face. And look at that, it moves right into place. However, there is one problem with this approach. If I zoom in here, we can see the clearance is just visible on this part and not on the other side. Also, this gap seems to be double the size of the clearance we gave. Let me cancel the join action. What's happening is that when we join two faces, it basically forces them together. What we need to do is place this part in between two faces rather than having it touch them. Let's select the joint option again. Here in the origin mode options, let's select this middle option which says between two faces. This allows us to choose two faces to define the space we are joining into. Let's select face 1 and then the opposite face. Finally, we'll select the origin, which is now defined in between the two faces. Now, in the joint panel here, for component 2, we can do the same thing and select the faces that will go in between the two faces of component 1. When we click the origin for these two faces, the top part seamlessly moves right into that space. How amazing! Now, we have the correct clearance for the two parts. Before hitting the OK button, we will go to the Motion tab here and set the type as Revolve. Then we can click OK. We can apply the same process for the hinge piece we created. So, selecting these two faces, and then the other two faces where they will join in between, and hitting the OK button. Perfect! We are done with our roller clamp. Now comes the interesting part, where we perform a section analysis to check if we have given the clearance wherever applicable. Under the Inspect option, when I click on the drop-down, I have the option to do a section analysis. So, let's select it. We are now given 3 planes to choose from. Let's select the XZ plane. When I hold this arrow and move it, I can see that it is slicing our model plane by plane, and we can see right through it. Obviously, we don't have any gaps on the front. But when I move this near the hinge area, I can clearly see these gaps in the middle of the two pieces, which is exactly what we needed. If I continue to go further back, we can now see the gaps between the rolling pin and the clamp pieces appearing. If we continue further, we now see the gaps between the shaft of the rolling pin and the other parts. I will cancel the previous section analysis and do the same with the XY plane this time. I will inspect the gaps from this angle. Everything seems fine. We can continue with the other plane as well. And that is how you perform section analysis in Fusion 360. That completes our 3D printable Fusion 360 clamp with a working hinge. If you followed all 3 parts, your model should be ready to print as one piece with smooth hinge motion. If this helped you, hit like, so more people who wants to print hinge-like mechanism using Fusion 360 can find this and avoid failed prints. Also, if you like my explanation, please like, comment and share. Subscribe to my channel. Don't forget to hit the bell icon. Your support helps my channel grow and continue to deliver high quality content.